Welcome to solverfy.
Okay, we are converting cyclohexanone and 1,2-ethane diol into an acetal. And the question is, what is the hemiacetal intermediate? That corresponds to this reaction. What is a hemiacetal? Recall that's when we went from having a ketone, well, not necessarily do we have to start with having a ketone, but that's generally what we're referring to. It's going from a ketone to the carbon no longer bearing a double bond to oxygen, but instead a single hydroxyl and a single ester functional group, right? And then when we complete the reaction, we get our acetal, in which both oxygens are esters rather than hydroxyls. Now, what's interesting in our case is that our final product is essentially this, except that rather than there being two individual R groups, the R groups are connected, right? Let me sketch that separately so as not to make it, or so as to make it a little more obvious, and I'll color code this, right? So I'm going to make the R groups red, and then when I draw a full bond line drawing of our molecule, I'll show what I mean by our R groups being connected, right? So you can think of this, everything to the right of this being an R group, or everything to the left of this being an R group, right? So what we need to do then is to take the structure we have and work backwards and say, what would the hemiacetal version of this look like? And the way we do that is we say, imagine we don't have this bond here, right? And then, so we would have O here. And rather than having a charged alkoxide, we would put a proton here to make it OH. And then we're going to do the exact same thing, but with the right hand portion. Sorry, my apologies. I put this line at the wrong spot. Okay. In either case, we're replacing what was this blue bond with this new blue bond to an OH. And then for the right hand half, that is this oxygen and everything here, we simply unfurl that. Instead of having it curved around, here we go, oxygen, carbon, carbon, and then bond to an oxygen, and we put a proton on that. So this is the product we're looking for, or the intermediate we're looking for, working backwards from the acetal to the hemiacetal, and that is answer C.